Alright, reference angles. Similar to coterminal angles in that they are the same initial and terminal side, but it's a different way to look at the angle. Also, like coterminal angles, an incredibly important concept that really helps simplify trig. So understanding the concept of a reference angle, how to find a reference angle, when somebody uses the word reference angle, knowing what they're talking about. These are all very important things, and yes, reference angle does actually come up in everyday conversations quite often when you become an adult. So you want to start trying to fit this into your vocabulary. I'd recommend starting off with 3 times a week, not including math class. Moving on. Reference angle. What is a reference angle? Again, this is on your sheet, and I already have some nice diagrams drawn for you on your sheet. The reference angle of an angle is the acute, so a couple things you want to highlight. It's an acute angle that the terminal side of an angle in standard position makes with the x-axis. So it is the acute angle that the terminal side of an angle in standard position makes with the x-axis. What does that mean? So if I have some angle here, let's call this theta, that's in standard position. So where is the acute angle that the terminal side makes with the x-axis? Well, since this angle theta is an acute angle, its reference angle is itself. So the reference angle, I'm going to call beta, is the same angle as theta. Okay, so that's kind of weird. Well, what if it's in the second quadrant? So now I have this angle theta in standard position. The acute angle between the terminal side and the x-axis is this angle here. So now there is my beta. That is the reference angle. Notice that it's very important now that we understand the word acute, because we know that the reference angle has to be a positive angle. So anytime we're referring to a reference angle, it is a positive angle. It is also an acute angle. If I'm in the third quadrant, this is my angle theta. Then there's the reference angle, beta. And if I am in the fourth quadrant, so I have this angle theta, then here's the reference angle beta. So those are basically the 4 positions of a reference angle. So why did I put a 5th axis down here, a 5th coordinate plane down here? Well, because we want to understand the idea of coterminal angles and reference angles. And so if I have, let's say, an angle in the first quadrant, but the actual angle is larger than 2 pi or 360 degrees, my reference angle is still just the acute angle. And again, that's going to be true in every single quadrant. So so for a given angle and all of its coterminal angles, they will have the same reference angle. Okay, so now if we want to actually figure out what is the reference angle of a given angle, well, it's easiest to do this graphically. And what do I mean by graphically? I mean draw a picture like I have here. So if I want to determine the reference angle of negative 20 degrees, Now this one you might be able to do without drawing a picture. We'll discuss that in a second. But for now, it's our first example. Let's draw a picture. What do I mean by that? Draw a little coordinate axis. Approximate negative 20 degrees. So if that's my angle theta, then what is this acute angle? Well, if the original angle is negative 20 degrees, this angle here, as an acute angle, is 20 degrees. So how we could have done this without drawing a picture is recognizing that the angle we're given to start with, if it's positive, is an acute angle. Since it's negative, we could have just made it positive, and we know then it would be itself. The reference angle would be that angle. What about 3 pi sevenths? Okay, so this might be a little more difficult. Now we're dealing in terms of radians. So approximately where is 3 pi sevenths on our coordinate plane? This is very important now to understand. So this is where we need to be comfortable dealing with fractions that I know in terms of sevenths. This is 0 and 14 pi sevenths. This is 7 pi sevenths. So 3 pi sevenths is somewhere between 0 and 7. What is this going to be? Well, this would be 3.5 pi sevenths. Therefore, 3 pi sevenths is somewhere in the first quadrant. And if this angle is in the first quadrant, then its reference angle is itself, because it is an acute angle. So now I want you to try and find the reference angle to 420 degrees and to negative 11 pi thirds. Pause the video, unpause when you're ready to check your work. Okay, so for 420 degrees, the reference angle is going to be 60 degrees. How do I come up with that? Well, first, I drew in 420 degrees. So I went around 360, and then how much more did I have to go? I had 60 more degrees to go. So since I was in the first quadrant, the reference angle is 60 degrees. Notice, here's the link, those are also coterminal angles. That is not always the case, but it will be if it's in the first quadrant. If an angle has a terminal side in the first quadrant, then its reference angle will be one of its coterminal angles. It will be the acute coterminal angle. Negative 11 pi thirds. This one I drew the angle. It ends up having a terminal side in the first quadrant again. So what is the positive acute angle, or what is the acute angle in the first quadrant to the initial and terminal side, or between the initial and terminal side? That is going to be pi thirds. So this has a reference angle of pi thirds. Okay, now I want you to go through and determine the reference angle of the remaining examples on your packet. 3 pi fifths, 4 pi fifths, 6 pi fifths, 7 pi fifths, 8 pi fifths, 9 pi fifths, and 25 pi noths. Pause the video, do that, unpause when you're ready to check your work. Alright, so for the first one here, we should end up with the reference angle is 2 pi fifths. How do I know that? Well, I know the original angle, 3 pi fifths, is in the second quadrant. So what is the remaining angle that will get me to the x-axis? That's going to be 2 pi fifths, because I know halfway around the circle is pi, which is 5 pi fifths. So another way to think about this is I can do pi minus 3 pi fifths, which is 2 pi fifths. And I can only do that because I know the initial angle is in the second quadrant. 4 pi fifths. The initial angle is also in the second quadrant. Therefore, the reference angle is going to be pi fifths. If I do pi minus 4 pi fifths, that's pi fifths. 6 pi fifths, now the original angle is in the third quadrant. The reference angle is still pi fifths because I am pi fifths away from the x-axis, which was 5 pi fifths. So here I can do 6 pi fifths minus pi, which is 5 pi fifths, and I'm left with pi fifths. Here again, I'm in the third quadrant for 7 pi fifths. So if I draw the picture out, I can ask myself, okay, what is the angle that I went past pi, and I went 2 pi fifths beyond pi, or 7 pi fifths minus pi is 2 pi fifths. 8 pi fifths is in the fourth quadrant. So now how much is left over to get to 2 pi? Because 2 pi is the x-axis in the fourth quadrant. And that's going to be 2 pi fifths again. Or 2 pi minus 8 pi fifths is 2 pi fifths. 9 pi fifths, very similar. So 9 pi fifths is in the fourth quadrant. I have pi fifths left over to get to the x-axis, or 2 pi minus 9 pi fifths is pi fifths. The last one, 25 pi ninths. Well, 25 pi ninths is greater than 2 pi. It has a terminal side in the second quadrant. And if I find the coterminal angle of it, I can do 25 pi ninths minus 2 pi, which is 7 pi ninths. So then I know that I'm dealing with an angle here. It is 7 pi ninths. So the reference angle is going to be the angle left over to get me to pi, which is going to be 2 pi ninths. Or I can do pi minus 7 pi ninths, which is 2 pi ninths. So those are the reference angles. Again, a reference angle is an incredibly important concept, especially when we are evaluating trig functions, because we'll evaluate them using the reference angle more often than not. So we want to understand what is a reference angle when we hear that term. It is the acute angle between the terminal side and the x-axis. It's very important that it's to the x-axis, so it is not just the smallest acute angle, but it's always the acute angle to the x-axis.